Hi students, today we will discuss the electrostatic potential energy of a system of n point charges. So if point charges are there in a particular configuration, then what will be the total potential energy of the system? So the basic principle behind is that if we are having a system of point charges, then the electrostatic potential energy will be equal to the work done in bringing those charges from infinity to their respective positions. So this is equal to the electrostatic potential energy of the system of n point charges. So now you see here, suppose we need to find out electrostatic potential energy of a system of n point charges. So first we will consider, suppose one charge is here, that is q1. So if we are bringing this charge q1 to this location, there is no external electric field here. So the work done in bringing the first charge w1 will be 0. Similarly, if we are bringing the second charge, suppose to this location, so in this case the work done in bringing the second charge from infinity to this point will be w2. So this w2 will be, we know when a charge body is brought from infinity to q2, this point, then here what is the potential due to this charge? This is suppose v1. So we know what is the potential at a particular point. So this v1 we know the potential at any point due to a source charge. This is equal to k q upon r. So r is the distance between the charge body and the point of the reference. So here w2 will be equal to q2 into v1. This already we are knowing. The work done is equal to, we know w is equal to v into q, that is potential and the charge. So in this case this will be equal to k q1 q2 upon r12. So here the distance between 1 and 2 is denoted by r12. So I think it is clear now. So now this is a system of 2 point charges. Suppose another charge, that is the third charge we are bringing. Suppose we are bringing the third charge q3. So the distance between these two will be, suppose r13. Here the distance between this will be r23. So in this case I have to find out what is the work done in bringing this charge q3 from infinity to this point. So let this work done is w3. So now you can understand here that when the charge q3 is brought to its original position, then the work will be done due to the potential due to the charge q1 at the point this q3, and also the potential at q2 due to q2 at point q3. So here I can find out the work done will be here q3 into v1 and q3 into v2. So this will be equal to here q3 into v1 plus q3 into v2. So what is v1? The potential at point this due to the charge q1. And what is v2? The potential at point this due to the charge at q2. So this will be equal to your q3. For v1 I can write this is k q1 upon r13. Similarly q3 into v2. So v2 will be k q2 upon r23. So if I will calculate this one, this will be k q1 q3 upon r13 plus q3. So this will be k q2 q3 upon r23. So here you can get that the total work done, if I want to find out, suppose the electrostatic potential energy of a system of charges consisting of 2 charges, then this will be w1 plus w2. If I am considering for 3 point charges, then this will be w1 plus w2 plus w3. Similarly, if this is 4 charges, so again w4 will be there. So like that we can summarize the things. So now I'll summarize the things. So for 2-point charges, the electrostatic potential energy U will be equal to W1 plus W2. So this will come as 0 plus K Q1 Q2 upon R12. Similarly, for 3-point charges, this will be U will be equal to W1 plus W2 plus this will be W3. So this will come as K Q1 Q2 upon R12 plus K Q1 Q3 upon R13 plus K Q2 Q3 upon R23. So in this manner, if we are having n-point charges, a system having n-point charges, so what will be the total potential energy? So here you can observe that we are moving in a sequence wise, and the product of charges and the distance between them, their sum we are taking. So in this case you can see that for n number of charges I can write this one like this. This K into this will be Q1 Q2 plus Q1 Q3 like that. This will be up to Q1 into Qn. Similarly Q2 Q3 plus Q2 Q4. So this will come up to like Q2 Qn. Similarly for Q3 we will start. This is a sequence wise, right? And the distances here will be R12. Here in this case this will be R13. Here this will be R1n. So like that we will get the total value of the potential energy. So in general terms we can write here this will be equal to K, that is summation of, I can write here Qi Qj upon Rij. Here you can see I am taking suppose Q1 Q2. So I will not be taking Q2 Q1. So if I am putting like this only summation, then Q2 Q1 will also come. It will also be summed up. So what I will do, I will just write here this is for pairs only. This is for pairs only. Right? Pairs means 1 2 and 2 1. This will be counted as 1 only. So this is the derivation for the electrostatic potential energy of a system of n-point charges. So this derivation is valid for the system of charges without any electric field earlier in that region. So in the absence of electric field, this derivation holds good. Suppose the same system of point charges we are placing in an external electric field, then what will happen? Then this potential energy will be there. In addition to that, suppose a charge body is placed in a electric field, then it will experience a force, so it will try to move. So to stop this motion we need to do some work. So this work will also be counted or summed up to find out the total potential energy of the system of charges. So here you can see if there is a presence of external electric field, then the potential energy U will be modified as the same. This will be the same one, like in pairs. This is equal to Qi Qj upon Rij plus, in addition to this you have to bring the respective charges in the electric field. It will experience some forces. So the force will be your Q1 V1, same manner this will be Q2 V2, Q3 V3, Q4 V4. So like that this will come as like this. So this will be the additional term in presence of external electric field. So now I think the concepts are clear. So thank you very much.